Hello everyone, welcome to solve this nice math Olympiad algebra problem. And here we have n cubed plus n equals 68, and we solve this problem for the values of n. So here first we focus on the right hand side, and we have this is 68, and we write it as n cubed plus n equals to this is 64, and we write it as this is 68, we write it as 64 plus 4. Okay, you know that 64 plus 4 becomes 68. And now in the next step here again we focus on the right hand side, and we write this is 64 as 4 cubed, and this is over 4. And now further here we move these two terms from right hand side to the left hand side, and it is written as n cubed plus n minus 4 cubed minus 4 equals to 0. So after this step here we need to make the pair of cubic term and the other term. So our cubic terms are n cubed minus 4 cubed, and the remaining terms are n minus 4 equals to 0. So after this step here we need a nice cubic formula, and you very well know about this formula. If we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. Okay, this is the our nice cubic formula which we just apply on the above term. So now after that here we just apply this cubic formula to the above term. So it will be written as this is n cubed minus 4 cubed, and we write it as n minus 4 times of n square plus n into 4 plus 4 square, and this is over n minus 4 equals to 0. Okay, after that you see here we have n minus 4 be the common term, so that we just take it common n minus 4, and the remaining terms are n square plus 4n plus 16, and here when you take common n minus 4 then you get plus 1 equals to 0. Okay, so after that here we need some simplification. You just add or subtract the like terms, and we write it as n minus 4 into n square plus 4n, and here we have 16 plus 1 becomes 17, and this is equals to 0. So further in the next step here we divide this question into the two cases, so that our first case is we just take this n minus 4 equals to 0, and the second case is we take n square plus 4n plus 17 equals to 0. In the first case we easily get the value of n is equals to 4, and this is the our first real root of the given equation. And now in order to find the other roots we need to solve this quadratic equation. So this is quadratic in y variable, so that here we easily apply the quadratic formula in order to solve this equation. So first we write the coefficients of this equation, and its coefficients are a equals to 1, b equals to 4, c equals to 17. And we know about the quadratic formula. It is stated as n is equals to minus b plus minus square root of b square minus 4 times of ac divided by 2 times of a. Okay, this is the our quadratic formula. And now here we need to substitute the values of a, b and c in this formula, and it will be written as n is equals to minus b, and the value of b is 4 plus minus square root of b square. B is 4 square minus 4 times of a is 1, and c is 17, and it is divided by 2 times of a, and our a is equals to 1. Okay, so further in the next step we have this n is equals to minus 4 plus minus square root of 4 square. So we know that 4 square becomes 16 minus 4 times of 17, is equals to 68 and it is divided by 2. So now we write this into the simplified form, and we have minus 4 plus minus square root of 16 minus 68 equals to minus 52, and it is divided by 2. And after that, here we need more simplification, and we write it as n is equals to minus 4 plus minus. Here we just separate the square root on 52 and minus 1, and we write it as square root of 52 and square root of minus 1 divided by 2. Okay, so here we have minus 4 plus minus, this is 52, and we write this 52 as 4 times of 13. We know that 4 times of 13 is equals to 52, and here we know that the square root of iota minus 1 becomes iota, and this is divided by 2. And after this step, you just see here, this is the square root on both of the combine of these two terms, and here we just separate the square root on both of these terms. It is written as minus 4 plus minus square root of 4 into square root of 13 iota divided by 2. So after that, you clearly see that the square root of 4 becomes 2, and we write it as minus 4 plus minus 2 into square root of 13 into iota, and it is divided by 2. And now after this step, we just break this fraction, and we write these terms as in this form: minus 4 divided by 2 plus minus 2 into square root of 13 divided by 2 into iota. Because here we write this we write the other roots of these questions are into the simplified form, so that here we need to break this fraction. So here you see that this 2 and 4 are cancelled by each other, and we get minus 2 plus minus. This 2 is cancelled out by this 2, and we get 13 square root into iota. Okay, so these are the other two complex roots of the given equation. So if you focus on the given equation, and you see that our given equation is the cubic equation, it means that the given equation has 3 solutions or 3 roots. Okay, so now here finally we have the first root of the given equation is n1 equals to 4. The second root of the given equation is n2 equals to minus 2 plus square root of 13 iota, and n3 is equals to minus 2 minus square root of 13 into iota. This is the our third root of the given equation. So these are the 3 roots, and this is the final answer of this question. And thank you so much for watching this video. Please subscribe to my channel for more exciting videos.